Hi everybody, welcome to this IBEF winter webinar. I am J Vandorme, bitumen emulsion expert for Secmer and SAE companies, part of Fire Group. My presentation will be a brief overview of solutions and technologies linked to bitumen emulsion production. This is a domain in which I've been working for 20 years. I will talk about three main topics: how to produce emulsion in an industrial facility, the design and the main items of an emulsion factory, and the quality controls. I will not go deeply into details of soap solution chemical reaction, but most of you must know that this is a very important step in the emulsion production process. First, let's talk about inline process for mixing of hydrochloric acid, emulsifier and water, main components of cationic emulsion. All the chemicals are mixed in one single pipe with a static mixer and directly sent to the mill for emulsion manufacture with the bitumen. Each dosing line is equipped with transfer pumps and flow meters. On this slide, you can see the two main parameters for emulsion process: chemical reaction with precise dosage and the mechanical sharing with the mill. The second way of preparing the soap solution is to use tanks in which we will inject the chemical products. The dosing of each of these chemicals can be done through flow meters, weigh cells, or dosing tank, as shown on this picture. The tanks where the mix is done are usually in polypropylene in order to avoid corrosion, and agitators are installed on the top to mix the different products. Once the mix is done, the pH is controlled and adjusted by adding some acid. The production of emulsion can be started and the mill produces emulsion with the bitumen. Here is a short video about the process with preparation tanks. You can see the fluid circulation and check the important steps. First, we inject the hot water, usually at 40 degrees Celsius, in the tank. When it's full, we inject the emulsifier and start the agitator. Next step is the injection of the HCl acid through dosing tank. The pH is controlled and adjusted if needed. After this check, we can start the mill and the emulsion manufacture process. While the tank is emptying, we manufacture the second tank with the same way: water, emulsifier, and acid. Some chemical suppliers recommend to inject the acid first, before the emulsifier. When the second tank is ready, we can switch from tank number 1 to tank number 2 and have a continuous production. For every tank produced, the pH has to be checked. While we switch from tank to tank, production of emulsion is continuous. The mill and the dosing pumps are running without any stop. Here is a brief comparison between inline process and continuous with tanks process. On the left, the inline production with static mixer. On the right, the preparation of soap solution into tanks. The main advantages of inline process are to start very quickly and switch from one formulation to another one very easily. The main advantages of tanks are the possibility to adjust the pH before starting the production and to have the possibility to test chemicals directly into the tanks. As we have seen before, the mill is an important tool for the emulsion production. Of course, you have many types of mills on the market, and they have all different characteristics. For SAE, we have developed our own mill based on parts and stainless steel because of the risk of corrosion. And we have an adjustable gap to control the viscosity of the emulsion, I mean the bitumen droplet size. Our mill is named Bitumil, and this slide presents the way we inject the soap solution and the bitumen inside. We have different size on outflow for this mill, according to the production rates you need. According to this outflow, the rotation speed and the power of the motor are adapted. There is an industrial unit with all the main equipments, such as the mill and the soap solution preparation. It is installed in a 40-feet container with a separate control room. You can see the preparation tanks in PP. The size and the materials of each line are adapted to the product, like PVC for acid and stainless steel for soap solution. The design of the entire unit is optimized to enable a quick and efficient maintenance. As seen before, the water used for soap solution is heated. The water management is a major factor in bitumen emulsion process. You need to know how to heat the water and avoid waste. You can see on this drawing that we get some calories back by cooling down the emulsion at the outlet of the mill. The idea is not to cool down with a low final temperature, but only to reduce the emulsion temperature by 15 degrees. This generates hot water in a buffer tank, which can be used again for soap solution preparation. For some specific emulsion, such as emulsion for microsurfacing, we have to design some special dosing lines. In this figure, you can see that we inject latex directly into the soap solution pipe just before the mill. There is also an additional cooler to be able to decrease emulsion temperature down to 40 degrees, which is the target final temperature for microsurfacing emulsions. The energy management is a key point in our industry. We have to heat the water needed to prepare the soap solution, and we have to heat the storage and the pipe of bitumen. Such energy spent has to be kept and used again in our process. On this slide, you can see on the left side that we have optimized the hot water generation, and on the right side that we have made a special study on electrical heating for bitumen lines and the mill. The energy saving can go up to 10 kilowatt per tons, and the electrical heating for the whole unit is less than 2.5 kilowatts per ton. Of course, our units can be fitted with a full computerized system which help to control the dosage and the quantities. With the help of the PLC, the operator can focus on quality and safety. The operator selects the formula of emulsion and the quantity he needs, and the system manages the complete operation, start, production, and stop of the unit. This is the general layout of a bitumen emulsion factory with the main items. Based on our experience, we can help our customers to design the entire project according to the configuration of the space available. You can see the main items such as bitumen and emulsion storages, but also the paths for the trucks to load and unload the different products. For the storage of the emulsion, the vertical version is the best in order to avoid the skin at the surface of the liquid. This fixed configuration is mainly chosen in case of big volumes of production each year. For the storage of emulsion, carbon steel can be used, and stainless steel is selected in case of very aggressive emulsion with high acid content. For mobile units and for small production, we can offer containerized storages in 20 or 40 feet dimensions. The heating is 100% electrical, and there is no need of retention tray. These containers are autonomous with embedded pumps for loading and unloading. A loading arm can also be installed to improve the flexibility. These containers are manufactured in our factory in France and are CE marked. On top of improved heating system and insulation, they are fitted with a full set of sensors to guarantee the safety. Concerning the safety, just few words about the labels which have to be clearly visible on the tanks. Each emulsion tank must have a sign with the capacity and the procedure in case of problem such as a leak. The personal protective equipment for the operators must also clearly shown. Our last development is the tiny mill with a small mill which enables to produce small quantity of emulsion. It is mainly used to test raw materials like bitumen. For example, every time you have a new delivery of bitumen, you can make a quick test before switching to industrial unit. This lab mill is easy to operate, to move and to clean. The electrical connection is standard with a single phase 230 volt socket. Besides the tiny mill, we are now able to supply lab equipment which are listed in European standard EN 13808. This test can be used for small samples of emulsion coming from the tiny mill or samples from the industrial unit taken during production. By using this test, you will have a clear idea of the reaction of the emulsion on the field during application. Last slide of my presentation. Here is the software we have developed in order to check the ROI, means the return on investment for setting up an industrial emulsion unit. According to the yearly production and the cost of energy and raw materials, we can calculate the profit and the consistency of the project. Thanks a lot for your attention. It was a real pleasure for me. Please contact us for any projects. See you soon.